Okay, now it's working. All right, so this is our basic quadratic. It's the most simple quadratic you can have. It's just x squared. What we can do for this is we can look at what's going to happen if we change this equation. We can think about what would happen to the graph. Okay, so if I'm going to graph, this time I'm going to graph y equals x squared minus 3. And I'm going to use a table again this time. Okay, I promise this is the last table we're going to do. But you can always use a table for anything. Let's do the same thing we did for the last problem, where we do like -3, -2, -1, 0, 1, 2, 3. Those are the numbers we're going to plug in. If we need to, we can put a few more numbers in there. So if I have -3 squared minus 3, what am I going to get there? -3 squared is going to be 9, and I will subtract 3. 9 minus 3 gives me positive 6. So I should get -3, positive 6 is my point here. If I plug in -2, that's going to give me 4 minus 3. You get 1 there, so -2, 1. Okay. If I plug in -1 squared minus 3, that gives me 1 minus 3. No, -2. So 1, -2 would be here. If I plug in 0, 0 squared minus 3, that's going to give me a -3. If I plug in 1, 1 squared minus 3, that gives me a -2. If I plug in a 2, I will get a 1. And if I plug in 3, I'll get 6. You can kind of, once you get half of it done, you can kind of look at the symmetry of your graph here. And so this would give you a picture of your graph. It looks a lot like the one that we just started with, except what has happened to it? It went down 3 units, which kind of makes sense because you're subtracting 3 from all of the numbers, right, that you would get. So we could graph every single quadratic just by plugging in numbers into a table every single time. But this takes a little while to do, right? So that would probably not be our #1 way of graphing a quadratic if given the choice. But it's always something to fall back on. So if you are ever not sure about your answer, just take a number, plug it in, see if that point is on the graph, right? So for this one, what we just saw there is what we call a vertical translation. You also see it called a vertical shift sometimes. It's when a function is moved up or down. The neat thing about this is it works for any function. Okay, so what I have right here is I did f of x plus k. If you have f of x plus k, the function is moved up k units. If you have f of x minus k, the function is moved down k units. This applies even whenever you're not talking about a quadratic. Okay, so it works if you have a line, it works if you have an absolute value function, it works for exponentials, it works for unknown functions that are just called f of x. So let's talk about this a little bit. You will primarily be looking at quadratics and test it on those, but I do want you to know that it works for all of these. So we'll see some notation here. So if I have example 3, that would be y equals x squared moved down 5. Okay. For example 4, I would still be dealing with y equals x squared. That's my graph. what's going to happen to it? It's going to be up 8. Okay, and it's okay that that 8 is out front because we could just switch the order, right? It's just addition, so we can switch that order. Now, number 5, my equation that I'm dealing with is not x squared. I don't have an x squared. What is the, what we sometimes call the parent equation? 2 to the x power. 2 to the x power is how we say that. And what has happened to 2 to the x power? It has moved up 9. So that would be an exponential function. Remember those exponential functions look like this? We talked about exponential growth. It would shift that up 9. What function are we dealing with for number 6? Okay, f of x. I have no idea what f of x looks like, right? That's just a name for a function. But I do know that whatever f of x is, what has happened to it? Down 7. Okay, questions so far? We're just thinking about what has happened to the graphs. Yep, what's going up or what's going down. All right, Zane, what would the equation be for number 7? So what we're starting with, like up here we had x squared was our equation. And right here we had 2 to the x power was our equation. And right here we didn't even have really like an equation that we know. It was just f of x. What would it be for this one? 3 to the x is how we say that. 3 to the x power. And what has happened to that graph of 3 to the x? Up 12. Very good. So if we add or subtract a number onto the end of the equation, it's going to move whatever function we had up or down that many units. So if I want to graph something like y equals 8 plus x squared, I know in my mind that it's going to be that U shape, but it's going to be moved up 8. So it would be that same U shape, but moved up 8. Like that. So it gives you a picture of what the graph looks like in your mind without you actually having to plot points. Right? All right, let's talk about something else. On Desmos, I want you to graph these 3 equations for me.
Like
all 3 of them together, yeah. They should show up as different colors whenever you do that. So on Desmos, I want you to type that in. Okay, so whenever you do this, you should get 3 quadratics here. Your colors may be different than mine. Mine are green and then purple and then black. So the green graph for mine in the middle, that's just our basic quadratic. It's not been moved anywhere. It's just that parent quadratic that we talk about, right? So the plus 3. So the one that has the plus 3, what happened to the graph? It went to the left, how many? 3. Okay? So I put the plus 3, and notice it's on the inside of the parentheses there. And the graph moved to the left 3. So like if I took the green graph and I moved it to the left 3, it would match that purple one. Okay? Julian, what happened to the x minus 5 graph? It's the black one on mine. Okay, which way? To the right. So it went to the right 5. So there should be a couple things that we notice here. Whenever we have our number that we're adding or subtracting on the inside of our parentheses instead of being at the end of the graph like it was for the others, what is it doing? Moving it from side to side. It's moving it left to right. And now, whenever I did these over here, if I put a plus 5 or plus 8, it went up 8. If I put a minus 5, it went down 5. But over here, what does a plus 3 do? Left. Now, on my x-axis, when I'm talking about horizontal here, this side right here is the positive direction, right? Right is the positive direction. Left is the negative direction. So, putting a plus 3 here caused this graph to move left 3. And putting a minus 5 here caused the graph to move to the right 5. So, if we look at these here, they're called horizontal translations. If I'm adding the k inside of the parentheses, k is just our number here, then I will go to the left k units. So notice there that positive and left, they're opposites, right? The left is our negative direction. So you're going in the opposite direction of whatever sign you have there. Here, if I have a minus, I go to the right. And this is all assuming that k is a positive number there. All right, so questions? All right, so if I look at these transformations, and we want to be able to do these. This is the sort of stuff you'll see without a calculator. All right, so it might ask you to match this to a graph. It might just ask you to describe the transformation. So for this first one, my equation would still be y equals x squared. That's the parent that I'm dealing with. I know because I see that square on the outside. And if I have a minus 9 on the inside, I know it's going to move it left or right. And in this case, negative should be left, but it goes the opposite direction, so it will go to the right 9. Okay, let's. I'm gonna pull up my Delta Math random name caller here to help me pick on you guys evenly.
Are you still recording?
Yes. A new recording, not the one that was going for 2 hours. 2 hours. All right. Let's see who gets to tell me about this one. Easton. All right. First of all, what's my equation? What is the function here? All right. We're starting with just a quadratic. And what's happened to this one? Left 1. Very good. All right, let's see who Delta Math wants to call on for this next one. Oh. I added her to my class so she can do some of the problems. Jada. All right, what's our equation for number 10? Yep. X squared, not x2. And what has happened to y equals x squared? No. No. Is this one in the parentheses? No. Down 5. All right, so when it's not inside the parentheses, when it's over at the end, that one moves it up or down. Okay, and if there are no parentheses written, there can be a couple of things. So, like, if there are no parentheses written, they go around whatever is squared, which is just the x here. Now, I do need some parentheses on number 11. Now, I don't have parentheses, but x and plus 3 are both in the numerator, or in the exponent there. So, pretend like they're in our parentheses. Okay? All right, let's see who Delta Math thinks can do this one. All right, Alyssa. Not quite. It is going to be y equals 2 to the x power. Okay? And then what's going to happen to y equals 2 to the x power? All right, so I said that that exponent is like it's got parentheses, right? So we're inside of the parentheses. When we're inside the parentheses, that's moving us left or right. Which one would it be here? Is left 3. Very good, because it's going to be the opposite direction where we have a positive 3. Normally positive would be to the right, but it's going to go opposite direction when it's inside of the parentheses. So that would be left 3. Okay, for 12, we got two things happening here. Let's see who can figure this one out. Let's see. Vince. Okay, first of all, what is my equation for this one? What graph would I be starting with? Good. All right, so we've got y equals x squared because we got that square right there. So we got two things that are going to happen to this. What's that going to be, Vince? Okay. All right, so what is that negative 4 going to do to the graph? Inside of the parentheses moves us left or right. It'll go right 4. So that minus 4 right there causes our function go to the right 4. What about that minus 3? Down 3. I almost think it's easier to do these when they have both there to keep them straight. Number on the outside is the up or down. All right, let's see. Any questions so far? All right, let's see who's got this next one. All right, Hank. What is my equation? What am I starting with for number 13? F of x is how we say that. F of x. And what has happened to f of x with that minus 2 that's put there? Very good. Right 2. It's inside of the parentheses, which moves it left or right. And we go the opposite direction. So minus means to go right. Okay. All right, let's try another one. Laura, what is my equation that I'm starting with here? So just the parent function is just going to be f of x. All right, so that is, we don't really know what f of x is. It's a mystery function. But the plus 3 and the plus 5 are going to have transformations for us. They're going to shift this in one way or the other. So what would that plus 3 do to the graph, Laura? Very good. We'll go left 3. And then what's the plus 5 do? Up 5. Very good. Okay. 15, these exponentials can be a little tricky. I don't think you're going to see a lot of exponentials, but you may, because we do cover exponentials in this class. So I threw a few in here. So when we have that exponent, you can think like it's got parentheses around it. So let's see who gets this one. All right, Zach. What's the parent function for this one, Zach? Very good. 3 to the x power. And we got that minus 2 and the plus 7. What has happened to this graph? up 7, right 2. So that plus 7 on the end makes it go up 7. The minus 2 in the middle, and the exponent goes right 2. Which order you say it in, it doesn't matter. I have been doing left to right first for all of these, but it doesn't matter which way. Okay? All right. We got one more thing that we need to look at. All right, so I want you to graph all 6 of these on Desmos. So, yeah, graph it on the same one. So graph all 6 of those on Desmos for me. Okay. All right, so what I did for mine here is I did my graphs that sort of went together in the same color, but I made the second one dotted here so you could follow it a little bit better, because once you start putting them all there together, they sort of run together a little bit. So the red was just x squared, and negative x squared, what happened to it? Flipped it upside down, right? Made a sad parabola, right? We knew that was going to happen because we knew that they were sad parabolas. Here I've got x minus 4 squared, which is this green graph. It actually just moved the red graph to the right 4. What happened when I put the negative out front here? Just flipped it upside down, right? Same thing with my x squared plus 5. What's happened to it? Just flips it upside down. So looking at these, what conclusion would you make about that negative added in? Okay, it is going to flip your equation upside down. So we call this a reflection over the x-axis, and it's written here for you. So a negative is going to reflect over the x-axis. Reflections must take place before translations if you're graphing these by hand. So notice right here, I'm going to get rid of these others right here. There's a difference. So you would flip the graph upside down first. So if I had like y equals x squared, and I was, whoever's got music on needs to cut it off, please. Somebody's definitely got it. Alright, so y equals x squared. I'll make it a different color here. Let's do red. Would be this graph. Notice that I would I wouldn't do plus 5 first and then put a negative out in front of the whole thing, because that would be different. What I would do here is I would flip it first and then move it up 5 there to get it to match. All right, so let's add in. We just got a few more that we're going to do, and then you guys have an assignment you're going to start on for me. So whenever I look at one like number 16, it's a little bit confusing. I don't like it when I have this number right here out front. So when I have that number out front, I can actually just move it to the end. And so if I move it to the end, I've got y equals negative x squared plus 10. So this would be y equals x squared. Okay. Marley, what does that negative do? It reflects it over the x-axis. So flip certainly is an okay word to use for your own personal thinking about, but if it's given to you on a test, it's probably going to say reflects over the x-axis. And then, Jada, what would the plus 10 do there? We'll go up 10. Very good. For 17, we're also going to be dealing with y equals x squared. So, Ayla, what's the negative going to do to the graph here? Very good. And then, Ayla, what will the minus 4 do? Nope. It's inside of the parentheses. Nope. Right 4. Yeah, you may need to look back at your notes as you do these, because you haven't. I've done these a lot, so I know the rules really well. You guys probably need to keep them close by. All right. Okay, Caroline, what about number 18? This time we're dealing with just y equals f of x. We got some mystery function here that we're calling f of x. So what will that negative right there do to the graph of f of x? It'll make it upside down, which is going to be reflect over the x-axis. And then what's the plus 7 going to do, Caroline? It's going to, not left. It's not inside of the parentheses. It's over here on the end, so it's going to go up 7. If it was inside of the parentheses, it would be left 7. But it is not. Okay. Wade, what about number 19? We got y equals x squared. What's going to happen to that graph? Left. Go opposite direction. So on your x-axis, positives over here on the right, negatives are on the left. It goes the opposite direction of the sign, so it's going to go left. 3. All right, what else? All right, so the 9 right there, I don't like it to be in the front. So I'm going to put it over here on the end. I'm going to get rid of it right here and make it plus 9 over here, right? So that means that I've got the plus 9 on the end. What's that going to do to the graph? It goes up 9. And then that leaves this negative right here in front of the parentheses. What does that negative do, Wade? No. When we're talking about what it does to the graph, it reflects over the x-axis. Okay. All right, questions? Just as we're not going to do this in this class, if you ever see a negative on the inside of the parentheses, like if I graph y equals negative x to the second, it doesn't look any different, right? It is actually different, but it doesn't look different. If the negative is inside the parentheses, it's going to reflect over the y-axis. You will not see anywhere this happens to you here because we just have to do like a really basic version of this. So you won't see this happen, but I just want you to understand that all of our negatives that we have out here are on the outside of the parentheses, and that reflects it over the x-axis. So when you get to Math 2 and look at other transformations, that doesn't confuse you. All right. So, questions? All right, you have a delta math, and you're going to start on it right now. Okay? It is going to give you, they did not have these problems in delta math, so I had to create them myself. So it will give you a second chance to answer it again if you miss it, but it is not going to let you go retake it. Okay? So I need you to do these problems. Right now, you may be able to get them done before we go because it's just thinking about what the graph looks like, right? So if we just look at the first problem, let me make sure you know how to type this in. So right here, well, let's see, let me go back. Let me do this. Sample student page. Foundations. Here we go. It's going to say it's late, but that's it. If I have problems in delta math, if I postpone them, I don't change the due date, so don't worry about that there. It's correct in Canvas. So I've got this equation right here. It is a quadratic. Normally, it would start off right here at the origin. What has happened to it? It's moved to the right 3. So in my equations, make sure you put a y equals in your equation. If you do not put the y equals, it's not going to count it right. Okay? It needs to be in the parentheses. Do I need a plus or a minus? Minus 3. It's got to be the opposite direction. So you got positive numbers over here. You got to put the opposite sign. And then do to the second. Just do shift 6 and second. Make sure you have the y equals or it's not going to count it right. Make sure your square is on the outside of the parentheses, and you'll submit your answer. So everybody should get that first one right. And so then it's going to ask you more. So like this one, what's happened to it? Up to, right? And so you're just going to answer these questions for me. Okay? Okay, do I need parentheses if I'm moving something up? Not if I'm only moving it up, right? So it's just going to be x squared, and I put the plus 2 over here on the end.
Okay, so it's got to be on the end of the plus 2?
Yes.
Okay.
Oh, let me go back and I am going to change the due date on this. Because it says it won't let you change your answers. It's due tomorrow at the beginning of class, but right now it says it's due. Okay. All right. It should